Okay, so here we are at 2-8. I probably cut off on my previous video there just because I realized it was the exact same problem. All right, but anyways, so we've done a lot of proving with segments so far. We can also prove with angles, okay? So let's go ahead and start with some of the basic angle properties, okay, that we kind of use to prove with. All right, this is the angle addition postulate. Now, that sounds very similar to the segment addition postulate. Okay, well, the truth is, it's almost the exact same thing, or let me just say, it is the exact same thing. It's just with angles as opposed to segments. Okay, remember, the segment addition postulate was two pieces add up to the whole, essentially. Okay, the angle addition for segments. And then for the angle addition postulate, it's just two parts of an angle add up to the whole angle. Okay, and that's exactly what we have here, right? We have this whole angle. Okay, we have the whole angle. And then we have these little pieces, right? So like just this plus this. Okay, so that's what it is. It's this kind of area, right? This area plus this area equals the entire thing. Okay, and I should be careful using area, but just that's space. How about that? So that space plus this space, right, equals that entire angle. Okay, so very similar, right? It even has it all laid out for you, right? R is in the interior of the angle. If essentially we have the fact that the measure of PQR plus RQS is equal to PQS PQS, so the entire thing. Okay, the supplement theorem. All right, if two angles form a linear pair, then they are supplementary angles. Okay, we've actually sort of talked about the fact that things are supplementary already. We've talked about linear pairs. Okay. This is just kind of a theorem to talk about that statement, okay? Very similar with the complement theorem. This is just a theorem to talk about the fact that, if two things, right, if two pieces that look like this, right, like 3 and 4, if they kind of fill up the right angle, well, then they add up to 90 and they're complementary. Okay, so these are kind of two facts that we've already talked about. It's just in like theorem form. Okay? Let's go ahead and talk about this one right here. Okay? So this is using complementary, and let's go ahead and begin. Okay? First of all, we got to talk about this symbol. AB is perpendicular. Okay, that's what it is, to BC. All right? I haven't even looked at the proof yet. We know that we're going to write given because that is one of our statements. Okay? So given here, because that's where it matches up with, right? There it is, given. Angle 1 and angle 3 are complementary. I know I'm going to have that at some point. Given, right? And, oh, here's my other given. Okay, so for whatever reason, it's at the very end, but I'll go ahead and write it. Angle 1 and angle 3 are complementary. Okay? All right. So let's go ahead and look at this right here in B. Okay? So the definition of perpendicular. Okay, so we've got to ask ourselves, what is the, how can we, what can we extract, right? What do we know about perpendicular? Well, if two things are perpendicular, that means we form right angles. Okay, that means we form right angles. So what we can say, okay, if AB, okay, that's this right here, is perpendicular to BC, well, what does that mean? That means angle ABC. Angle ABC is a right angle. Okay? ABC is a right angle. Well, what does that mean? Okay, well, that means the measure of angle ABC is equal to 90. That's the definition of a right angle. Okay? Then on this next one, right, because we filled in those gaps. Okay, well, the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. Okay, let's look and see what this is really talking about. The measure of angle ABC. So when we see something, we should go find it. Here's A, here's B, here's C. Okay, so here it is. Angle ABC. Okay, consists of angle 1 plus angle 2. Okay, well, that's the angle addition postulate because I'm looking at two pieces adding up to the whole. All right, so this is the angle addition postulate. All right, and then substitution. It actually does this entire step for you. Let's just note why we know that. Okay, so look, we've got the measure of angle ABC. We know that's 90. Okay, and it has the measure of angle ABC here, right? So instead of the measure of angle ABC here, I'm writing 90. Okay, so let's just kind of recap what we've already have. We have used this fact. We haven't used that yet. That's already here. We've used that fact. We've used that fact. We've now used this fact. Okay, and we by the way, we just used this fact, right? That was with the substitution. We used that fact and we used that fact to make this part. Okay, and what this is saying is it's saying 90 is equal to the measure of angle 1 plus the measure of angle 2. That means angle 1 and angle 2 are complementary. Well, that's the definition of complementary. Okay, you could also say the complement theorem, either way, all right? Either one of those is perfectly fine, okay? And then on this last step, okay, it seems to make a big jump here, all right? But I want to point out that where this is coming from, you should have gone over this before, but we'll go over it real quick. That's okay. All right, this is the congruent complements theorem. Okay, I'll go ahead and give you that step. Now, the reason why it's the congruent complements theorem is because of this. So the angles complement to the same angle, or two congruent angles are congruent. So let's think about what this means. This is a good example to talk about this one. Okay, it's saying 1 and 2 are complementary, and 1 and 3 are complementary. Okay, well, so it's saying 1 and 2 are complementary, right? And then 1 and 3 are complementary. So you can kind of actually substitute, right? Right? You're saying 2 is complementary to 1, and 3 is complementary to 1. So they're both complementary to the same thing. They're both anchored kind of to that 1. Therefore, these two are the same. That's what this theorem, the congruent complements theorem, is saying. Okay? Because this angle, right, these 2 is congruent to 1, 2 is complementary to 1, 3 is complementary to 1. Therefore, these two are the same. So this is the congruent complements theorem. Okay? And that is that proof. All right? Last one. Okay? Last one. And actually we're going to go over these real quick. So the congruent supplements theorem, almost the exact same thing as what I just did. It's just when two angles are supplementary to the same angle, okay, then those two angles are congruent. So very, very similar to this right here. It would just, instead of 90, right, it would be 180. Okay, that's the only difference. Okay, but it's applied in the same manner. Vertical angles theorem, that one might show up, right? If two angles are vertical, then they're congruent. We've talked about that fact before, right? It's, remember, the vertical angles are the ones where they kind of cross and they're here and here, okay? And so if you have two angles in the vertical, then they're also congruent, okay? And these few theorems in here are part of it. It's mostly, a lot of these we can kind of think through why they're the case, but they're somewhat kind of standard, right? Or they're really, really not too complicated, right? It makes sense, right? Let's just read the first one. Perpendicular lines intersect to form right angles, right? Makes perfect sense, right? Think about any intersection, right, when you're driving. All right angles, okay? And so a lot of these are, not, I don't want to say common sense, but more like just relatively simple properties, okay? All right angles are congruent, okay? Well, that makes sense. They're all 90, okay? So they're all the same. Perpendicular lines form congruent adjacent angles. Yep, because they're all 90, okay? Again, they're all 90, so of course they would all be congruent and adjacent, okay? And it's just saying that they're all touching with the adjacent part. 2.12, if two angles are congruent and supplementary, then each angle is a right angle. So maybe this is one we can talk about, okay? If two angles are congruent and supplementary, okay? So they have to be the same and they're supplementary. So think about this, right? It's like x plus x equals 180. They're the same. X is the same as x. That's the congruent part. And they're supplementary. That's the add up to 180 part. Well, if we were to solve for x here, you're going to get x is 90. Okay? So, and then, of course, they would have to be right angles. Okay? And then two congruent angles formally pair, and they are right angles. That's very similar to what we just did. Okay? All right, so here we go. Last proof, and then we are done. Okay, so 1 and 2 form a linear pair. Okay, 1 and 2 form a linear pair. Cool. It's a given statement. We'll have to use it, right? We know we're going to have to use it at some point. Okay? But here we go. It's already given, right? Given here. All right? Keep in mind our goal is to show 2 is congruent to 3. Okay? The supplement theorem. Okay? Well, the supplement theorem, right, just says that if, let's just recap it. Okay? If two angles have a linear pair, then they're supplementary. Okay? So all we're saying here is we will say angle 1 and 2. Let's be consistent here. Angle 1 is supplementary to angle 2. Okay? And we've now extracted information from that. Okay? And that is just using the supplement theorem. If something's a linear pair, then it is, if angles form a linear pair, then they are supplementary. Okay? So that's why we know angle 1 is supplementary to angle 2. So we've used this. Okay? And then we're now going to use this. Measure of angle 1 plus the measure of angle 3 is equal to 180. We know angle 1 is supplementary to angle 3. Again, that's the supplement theorem. Okay? Okay? Because we know if they add up to, not supplement theorem, but definition of supplementary. I mean, really, you could use either. They're very similar. But essentially, this is the definition of supplementary, because that's what supplementary means. Supplementary literally means two angles adding up to 180. Okay, so if you have measure of angle 1 and angle 3 adding up to 180, well, then they have to be supplementary by the definition of what it means to be supplementary. Okay. But even if you just sort of put supplementary, I'll probably give you credit there, right? That's just because if you can see that information, then I know you're kind of getting the bulk of what needs to be pieced together. Okay, and then this last part, right? This is actually we're using a congruent supplements theorem, which again, right, is 2 supplementary to 1, 3 supplementary to 1. That means that these two are the same, and of course, we would know that anyways without that reasoning, because that has to be our last step. Okay, so that's kind of a further second day of proofs. Okay, again, these things aren't easy, but if you do a lot of them, they start to be some of the same processes, right? Substitution, segment addition postulate. Maybe we're using definition of midpoint. Okay, maybe we're using linear, definition of supplementary. Maybe we're, whatever it is. So you can see like there's a lot of common steps, okay? But we are, the goal is to work our way to being able to do these ourselves, okay? But it is hard, right? But, we try to just do the absolute best we can with these, all right? But that is all I have for today. You guys take care and have a great day or evening or wherever you're at on that. Y'all have a good one.